Okay, hi all. I'm Ronit Belson. Hold on, this doesn't work. Doesn't work.
Try now.
Okay. So my name is Ronit Belson. I'm the CEO and co-founder of Sawmills. A little bit about myself. I have over 20 years of experience in developers and DevOps tools, companies, wore every hat possible besides running engineering. So what is Sawmills? Sawmills is a smart telemetry management platform. What we do is we continuously analyze telemetry data with two purposes in mind. The number one purpose is making sure that the telemetry data is of high quality, so we enhance the telemetry data quality. And then the number two goal of Sawmills is to reduce operational costs, which, as we all know today, are extremely high. What we'll do today is not talk about Sawmills, but we will talk about some of what we learned while running and analyzing huge amounts of telemetry data. Our focus today is going to be logs. So we'll share with you some of the insights and what we learned as we analyze a lot of data. As we all know, logs, again, as I said, we're going to focus on logs. As we all know, logs are used for different use cases, different groups in the organization. So security is using it to find some security breaches. It's used for audit. It's used by the business groups for analytics. And it's used by engineers for root cause analysis. And what we're going to focus on today, within the vast amount of use cases for logs, we are going to focus on root cause analysis and what can you do with logs and telemetry data in order to improve root cause analysis. So what are the challenges? As we all know, logs are very often used for root cause analysis. However, it is a little bit like looking for a needle in a haystack. What makes it difficult? Few things. Logs can be highly repetitive. The more data that you send into your observability solution, the more of low quality that data, the more difficult it is to do root cause analysis. So logs can be repetitive. Very often, they're very verbose, a lot of words to say something that you can say with much less words. A lot of times, they're unstructured, so when you're looking for that needle in the haystack, it's really hard to find. Often, they're written by another team, so you didn't write the log, you don't know how to search in the log, even more worse, by third parties. You don't know the context of the logs. They are human written, so one developer can call one thing in one word, another developer will call it in another word, and then when you go and search for the log, for what you're looking for, it's really hard to search. And the last problem is the logs are atomic units, so they don't carry the context. Sometimes the context is carried when in more than one log, and when, again, you're looking for the root cause analysis, it's really hard to find the root of the problem.
Hi everybody. Erez, I'm one of the co-founders. I lead the product at Sawmills. I have experience both as a DevOps engineer and an observability engineer many years ago. And it says over here, better RCA, better root cause analysis, better data, equals better data. And what we want to make the claim is that if you want to improve your root cause analysis, you need to have better data. And I'll show you some of the insights or some of the data problems that we found across our customer base. And this is very repeatable, and I'm sure some of you will identify with some of these problems. We talk about some of the solutions, and then we'll even talk about one problem that is unique that we've managed to solve with an LLM, with an AI in this case. So first problem, and I'm sure a lot of you have seen this, the burst of a repetitive log line, either a warning or an error message. It could be authentication issue, could be service unavailable, could be connection issue. Very repetitive, doesn't include any new information across these log lines, pollutes your database, masks a lot of the issues. Again, goes back to the needle in the haystack. And this could be lingering issue that you have in your system, or it could be something that happens and goes away. And even the best engineering teams and platform teams, they cannot expect this because it comes and goes depending on how the system was built. So that's an issue that we keep on seeing with the data. And again, think about data issues that impact root cause analysis. The other issue that we've seen is the verbose logging, and that could be complete SQL queries, complete payloads, stack traces, things that are questionable in the observability vendor of choice that you guys are using. They're not helping you find the problem. Another issue is with third-party services. And this could be libraries, could be services, it could be frameworks. Essentially, if somebody is using some framework in the organization or some library, nobody in the organization wrote these logs. Nobody actually knows what they mean, and you've just added a bunch of logs to your system. Again, they create a lot of logs. Some of those are not needed. Some of those, nobody really understands what they mean, and these actually need to be fine-tuned in some cases. And so over here you have, Kubernetes, like secrets, and you have DNS, and you have Argo CD, and so forth. The famous health checks or status checks. We see a repeated log line on an endpoint that has the status code and the duration of a GET or POST request. Very repetitive, again, questionable in terms of how much value it gives you, pollutes, again, the database. Hard to do root cause analysis because this is not giving you more information. We have a few more issues to go through. The famous multi-line. Multi-line is essentially when you're sending stack traces, when you're sending tabular data, the log line breaks, and it's now repeated across many log lines. And it's not repeated, but it breaks across log lines. And so what ends up happening is that log line becomes unusable. Nobody understands what it means. Essentially, the log line breaks. And so, again, some data that is not needed, masking other data that you do need. The last problem that we've seen is the attributes, the metadata attributes across the log line. So again, log lines, the gist is in the body, is in the message, but there's a whole lot of attributes that surround each log lines. And some of these attributes, you get it from Kubernetes, you get it from containers. Some of those were added. Some of those are redundant. Some of those are duplicate. Some of those are too verbose. You could look at the bottom, you see the actual file name where the log line sits. You could see the folder. I mean, this information, nobody needs it. And the real problem happens when you have duplications. So then if somebody is using that, then that creates downstream implications, especially if you use that in dashboarding, et cetera, then you might make mistakes. OK, so we covered a lot of problems. The question is, what can we do? And so first of all, you have to clean the log lines. You have to, again, you want to do root cause analysis. You need to keep hygiene of your data. If you don't keep the hygiene, you're going to get lost. And hygiene means removing some of it, but it also means transforming some of the data to a better data format. So the easy solution, converting unstructured logs to structured logs. Observability data should be structured. It's easier to query. It's easier to create dashboard, et cetera. And that can be done easily with all the log shippers, the log stash, the fluent bits, the hotel collectors, et cetera, or it can be done on the code level itself. Sampling repeated log line, the famous health check, right? Do I need all these health checks which have a status of 200? Do I need them really, or can I sample just 1%, 5% out of them? Aggregation, I'll show you in a second a nice example. Aggregation is probably the most powerful tool today where you can aggregate similar messages and actually extract some of the changing values and summarize them. And I'll show you an example around this. Converting log into metrics. So if you have log lines that says, latency, duration, any numerical value, many times it should not be in a log file. It should be in a metric. The format of a metric is way more usable, and that could be used for alerts and not the log lines itself. Again, hygiene. Get rid of the junk in production. Get rid of the debug message, the stack traces. This is polluting you, and it's hard to find the root cause of the issue. Ronit mentioned initially that some log lines are used for security, audit, compliance. See that you route those logs to where they need it. Do you need that in your observability vendor? Why is that there? And the last piece is that you should standard your attributes, right? Make sure that there's like an allow list or a whitelist, and these attributes are accounted for. So these are the easy solutions to the more common problems. And yet, I wanted to show an example of aggregation. So you can see on the left side the repeated status check. And on the right side, you're seeing an aggregated form factor. And if I zoom into that, you could see that I see how many times that repeated. I see the average duration, the minimum, the maximum. So it's not just that it's more condensed. It actually has more information for you to use. You actually gain better insights into what's happening in your environment. OK, so we talked about a bunch of problems, but we haven't covered one problem that Ronit alluded to, which is the context, right? Log lines are isolated, right? That's how the nature of log lines, right? Each log line is by itself. It's not connected to the other log lines. So it's fragmented. It doesn't tell the story of like cause and effect. And we've all been to that situation where you have to search, you find a log line, then you find the next log line, and you find the next one, and you lose yourself, right? And so this is kind of a hard problem to solve because that's how log lines are built. Each log line is by itself. So hard problem. And we asked ourselves, how could we solve this hard problem? How could we reconstruct the narrative? How could we tell the story that the log lines want to tell us, but it's super fragmented? So can we do that, leveraging a large language model? And so high level, the solution, and I'll dive into the details, but high level, the solution is mapping the connection between log lines with a trace ID or a transaction ID. Most cases, you will find something that connects the log lines, right? So you find these connections, and then once you find the complete connection of a transaction or a trace ID, now you can actually summarize what happened across the transaction and represent a unified message that actually tells the story, right? So let me show you an example. So this is a simplified example. It's a real example, but very simple. This is a service that we've done exactly that for. And what we've done is that we sampled data from the service. We looked at all the transactions that happened. We looked at all the log line patterns that happened, and we grouped them by a transaction ID, right? And then we built this tree that each node represents a log line. And you can see also there's a number over there that shows how many times that repeated. And so we created these paths, these tree of transactions. And now we could summarize each transaction. And instead of sending 5 logs, we could send 1. And so this is in this example. So there's 5 paths. Just if you look at the third row, the authentication path. Now you have request processing started, authentication successful, request processing completed, right? These are complete separate log lines. We connected them to one. And when I say summary, this is, again, a summary for observability. That means that it's a structured log line that has all the information. And so we've done that, and that's how it looks. Instead of having 3 different log lines on the left side, you have 1 log line that tells the story on the right side. OK, so this is how it looks in real life when we map this to bigger services. So it's super, super messy, and sometimes you have hundreds of paths, and each path has hundreds of nodes. And so the nice thing is that, like any other thing in life, Pareto wins. So 80% of the volume is generated by 20% of the transactions. And so even on large services such as this one, basically, it boils down to 10, 15, 20 paths that you could summarize. So what we do is that we summarize those, we extract the patterns that create those, and then we know how to replace those in runtimes. And that's super meaningful because then you get the story. So I think we're reaching the end. So just to summarize, if you want to do better RCA, you need to have better data. To have better data, you need some hygiene. You need to clean the mess. You need to get rid of the mess. And you also need to transform some of the form factor to a better one. And that could be aggregation. That could be turning that into a metrics. But it also means sampling some of it. The interesting piece, I think, is that you could summarize transaction and get the full story from disconnected log lines. And it doesn't matter, we all think that at one point, agents are going to read the log lines. They need better data as well. There's a bonus to this, is that you pay less because you're sending less data to your observability vendor of choice. And that's funny because that's where we started. That's what we wanted to do. But then we figured out that we could actually improve the data. Thank you, everybody. Feel free to contact us. We have a QR code over there. And if anybody has any question, we'll be happy to answer anything.